All right, so here is your review. Hopefully you guys have had a chance to do it. I'm going to go over it kind of like how I do in class, and hopefully this will be helpful for you to study for the test that's on Friday. So it says the Excellent Drug Company claims its aspirin tablets will relieve headaches faster than any other aspirin on the market. To determine whether Excellent's claim is valid, 30 volunteers who are suffering from headaches are randomly assigned to two groups. The subjects in one group are given Excellent's aspirin, and the subjects in the other group are given aspirin from the Simple Drug Company. The number of minutes required for each subject to recover from the headache is recorded. A 5% significance level test is performed to determine whether Excellent's aspirin cures headaches significantly faster than the Simple's aspirin. The data were analyzed with Minitab, and the following output was obtained. So you can see the two drugs, Excellent, Simple, the sample sizes with the mean, standard deviation, and remember this is the standard error. That's what that means, okay? They actually give you a lot of information in here. They give you the estimate, which is your statistic. This is saying your null hypothesis equals 0 versus not equal. Okay, that's what the null and alternative are. This is the t-value, or in other words, test statistic. Your p-value for a two-sided test, because it says versus not equal, and the degrees of freedom. So they actually give you all the information you need. So what are the appropriate hypotheses for this test? And it says that it's against a no versus not equals. So what you want is the Excellent minus Simple equals 0 for the null, and the not equals for the alternative. So your answer is B. All right. Number 2, I should have scrolled down a little bit further. Number 2 says, which of the following is the most appropriate conclusion at the alpha of 5%? Well, here's the p-value, okay? So that p-value is less than 5%, so we should reject the null hypothesis. We never fail to reject. I'm sorry, wait, no, that's way wrong. Our p-value is quite high. The p-value is 0.37. That's much bigger than the alpha level of 0.05. So we don't want to reject. We want to fail to reject. We never accept the alternative or the null hypothesis, ever. So we need to fail to reject. Now, that goes between sufficient or insufficient evidence. In our case, we always say weak evidence. So weak evidence is the same as insufficient evidence. So we fail to reject the null hypothesis. There is weak evidence to conclude that the Excellent cures headaches faster than Simple. So E would be the correct answer there. All right, I'm going to have to again scroll down to get to the next problem. Excuse the line across the screen. My program does that a little bit. All right, so again back to type 2 problems. Or type 2 error questions. If the company performing this test committed a type 2 error, which of the following describes what happened? Well, remember, if we did a type 2 error, we failed to reject, which means we did not conclude the alternative, okay? So anytime it says the company concluded, we did not conclude. So the company concluded that Excellent's aspirin works faster. We don't want to use the wording has concluded. We want to use the wording that they have not concluded. So the company has not concluded that Excellent aspirin works faster than Simple aspirin when it does. That's what I noticed that you guys struggle with, is a lot of people want to say concluding. But with fail to reject, we did not conclude anything. So the answer in this case would be B. We did not conclude that Excellent works faster when it really does. All right, so let me clear this out now and scroll on to the next page. The following are percents of fat found in 5 samples of each of the 2 brands of ice cream. Which of the following procedures is an appropriate test to test the hypothesis of average or equal average fat content in the 2 types of ice creams? Now, they're trying to confuse you here. We've got a paired t-test, which is the same thing as a matched pairs t-test, or a matched pairs test that we did last chapter, and they say that twice with the degrees of freedom or a degree of 5 or 4. Or they say it's a 2-sample t-test with 2 different degrees of freedom, or a 2-proportion z-test. Well, I can tell you right now it's not a 2-proportion z-test because it's not proportions. We're looking at fat found in the sample. So these are averages. Okay, so these are means. Now, a paired t-test is, again, when you take one sample and you do like a matched pairs design to it. In this case, we took 2 completely separate samples, so it's actually not going to be a paired test. It's going to be a 2 sample. So then the next question is it a degrees of freedom of 4 or 9? The 4 is they're saying there's 1, 2, 3, 4, 5 samples, so 5 minus 1 versus adding them all up and saying 10 minus 1. Remember, we just pick the one of the samples, and it's the one with the smaller sample size you do degrees of freedom minus 1. So in this case, they're the same sample size. So we want to do a degrees of freedom is equal to 5 minus 1, which is 4. So the 4 degrees of freedom is the more appropriate one. That's the conservative approach since we're not using a calculator here. So degrees of freedom of 4, B, is the correct answer for number 4. Number 5, an ecologist studying differences in the populations of a certain species of lizard on 2 different islands collect lizards in live traps. They weigh them and release them again. He marks them so he won't weigh them, the same lizard, twice. During one study period, he collects the following data. All weights are in grams. Now, make sure you're paying attention. Well, I guess in this case we don't have to worry about it, but anytime they give you tables, make sure you pay attention to the sample sizes. In this case, they just want to know how do we calculate the test statistic appropriately. So in this case, remember the test statistic formula is test statistic equals statistic minus parameter divided by the standard deviation of the statistic. So as you can see, all of the test statistics should be T. Now the statistic should be the subtraction of these two. So you notice that it is 46.5 minus the 44.2 minus a parameter of 0. Well, they don't show the 0 on here, and that's okay. Hold on a second. My mouse is messing up. Hold on. All right, I got my mouse working again. So we have the statistic, which is the subtraction of the two means, minus the parameter of 0. As you can see, they don't even show the minus 0, so that's okay. But divided by the standard deviation of the statistic. Well, remember, you guys, that formula for us is the S1 squared over N1 plus S2 squared over N2. So we need the variance, so we're going to take the standard deviation, 5.97 squared, over that sample size of 24, plus the other standard deviation squared over that population size. So then we take the square root over the whole thing. So if you use your formula that you know, then you just have to come over here and compare. Which one is the correct one? Well, this one they forgot to square it. This one they have the correct subtraction. They square these over the right ones with the square root. So it looks like C is the correct answer. I'd have to scroll down for E, but even E has the issue. E, they combined the totals down here. So again, the correct answer there is C. Okay. All right, let's move on to the next one. Use the following for questions 6 through 8. Janice and her cousin Linda are a little competitive about the relative merits of their hometowns. One contest they had was to determine who had more rainy days. They found weather records on the internet, and each of them randomly selected 60 days from the past 5 years. Janice found that there had been measurable rainfall on 17 of the 60 days she selected for Asheville, and Linda found that there had been measurable rain on 12 of the 60 days she selected for Lincoln. They intended to perform a test of significance on their data using the hypothesis, the null hypothesis, that there's no difference, versus that there is a difference. They don't know which one's higher, so they just said that there is a difference at the 5% significance level. Remember, this means it's a two-sided test. When calculating the test statistic, what expressions would they use to estimate the standard deviation of the sampling distribution of the differences of proportions? So in other words, standard deviation of the statistic. Okay? Well, again, we're dealing with proportions here. What's the proportion of the rainfall? Because we're talking about 17 of the 60 days, 12 of the 60 days. Because this is a significance test, we want to use the idea of P hat C. Okay, so I need to know each of them individually. Again, I'm having a little bit of mouse issues. There we go. So we got to remember, P hat 1 is 17 out of 60. P hat 2 is 12 out of 60. But because we're doing a significance test for proportions, the standard deviation of the sampling distribution assumes there's no difference. So we actually need to use the idea of P hat C. To find P hat C, we do 17 plus 12 over 60 plus 60. So in this case, that's going to be 7, 8, 9, 29 over 120, which gives you a P hat C of 0.24. So when you come up with the formula, remember it's P hat C times 1 minus P hat C over N1 plus P hat C times 1 minus P hat C over N2. Well, in this case, our P hat C is 0.24. That's going to go in both of these. So that's the square root of 0.24 times let's see, what is that? 76 all over the sample size of 60, plus you do it again, 0.24 times 0.76 all over 60. I know it seems funny that we're doing it both 60, but those are the two sample sizes. So then I, again, like to write this out myself and then go back and compare the answers, because otherwise it gets a little confusing. We want one big square root. I don't like this one because they use the individual totals, but this one's looking good to me. They use the P hat C over the two sample sizes. So D is the correct answer on that one. All right, so moving on to question 7. Janice and Linda's test statistic was 1.07. So in other words, Z was the 1.07. Which of the following is the closest p-value? Well, remember it was a two-sided test, you guys. So be careful. I would look up well, if you're looking at the picture, because remember we always make a picture. We'd say, here's 0. Our test statistic would be the 1.07, but that means we'd also have a test statistic of negative 1.07 on the other side. So if you find the area, well, the area of one of those is 0.1423. So remember, you got to multiply that by 2 since it's a two-sided test, which gives us the 0.2846. These questions are really crucial that you pay attention to what the alternative is. I know they sound like they're really easy. You just got to look it up on table A, but you really do have to pay attention to the fact that if it's a one-sided test versus a two-sided test. Okay. All right. So, hold on a second. Let me clear that. All right, and then number 8, which of the following best describes what it would mean if Janice and Linda's test resulted in a type 1 error? Again, here's these type 1 and type 2 error questions. Remember, a type 1 error would mean that we reject, and if we reject, we conclude the alternative. Okay? Well, in this case, the alternative is that there was a difference in their of the rainfall in their two cities. So we don't want to say choosing the wrong test. We never want to be saying accepting the alternative or accepting the null hypothesis. In fact, we never, ever, ever accept the null hypothesis. So in this case, we're concluding that there is a difference because that was the alternative. We're concluding there is a difference in the two cities when really there was no difference. Okay, so again, type A is the next question. All right, you guys, I am going to create one more video for the last couple multiple choice questions. Okay, sorry for the crazy scratches there. But go to the next video for the last couple multiple choice questions and the free response.